The position vector of a particle p at time t is given by r is 3t squared minus 2I plus 2tj. We want to find the velocity when t equals 2. So we have that r is 3t squared minus 2 and 2t, writing our vector as a column vector. For velocity we need to differentiate r, so we just differentiate the I component and then differentiate the j component. So when t equals 2, v is going to be equal to 6 times 2, which is 12, and 2, which is 12i, plus 2j meters per second, if we write in ij notation. We now want the speed at this same time. We know the components are 12 and 2. The speed is going to be the magnitude of this vector. So we know that our motion is going 12 units across and 2 units up. The length of the third side of this triangle is the speed. So v squared is 12 squared plus 2 squared, which is 144 plus 4, which is 148. Therefore v is the square root of 148, which is 12.2 meters per second, correct to 3 significant figures. Now in part C we want the acceleration when t is 2. We know the velocity is 6t and 2. The acceleration is going to be the differential of the velocity, which is 6 and 0. This is a constant. There is no t involved, so it's going to be 60 irrespective of the value of t.